We did the eighth chapter last time, that was circular measures, and the next one is trigonometry. There will be few things in addition to simple maths. Starting with the basics, prerequisites. Do we remember how to use Pythagoras theorem
Yes.
and trigonometry to be applied on right angle triangle, like sine, cos, tan?
Yes.
Pythagoras theorem was hypotenuse square is equals to base square plus perpendicular square. And then sine theta is
Opposite over hypotenuse.
opposite over hypotenuse.
And then tan is opposite over adjacent. And then cos is adjacent over hypotenuse.
Okay. And then converting between degrees and radians. We did this in chapter 8, circular measures. 180 degrees is equals to pi radian. So basically, 1 degree will be equal to pi by 180.
And then radians itself is degrees times pi by 180.
And 180, 1 radian will be 180 over pi. Just simple cross multiplying.
Okay.
Main is this, or 360 equals 2 pi, and we would just put the angle and cross multiply. Then solving the quadratic equations. X square plus xx is equals to 0. You can take x common. This is x plus 6 is equal to 0. These are two factors. First one equal to 0, second one equal to 0, and x is equals to minus 6. And so on. Angle between 0 and 90, you should already know the following trigonometric ratios. We just discussed them, sine, cos, and tan. Moving on, given that sine theta is equals to 2 by square root 5 and theta is acute, find the exact values of these. So when we have this, we can just substitute the values. Sine theta, I'm just making that triangle at a little earlier stage. This is, let's say this is theta, and it is given sine theta is 2 by 5. We know that sine theta is opposite over hypotenuse. So opposite with respect to theta is this side, which should be 2, and hypotenuse is square root 5. Now we know that we can find the third side using Pythagoras theorem. So hypotenuse square is equals to one side square and then the other side square. So solving this is 5, 4. 5 minus 4 is 1. Square root both sides, x is equals to 1. Third side is 1. Now we can just use values for sine, cos, and tan from this triangle to solve the given questions. Sine square. So sine square is simply 2 by square root 5 squared 4 by 5. And then it says cos theta. We've already worked out the triangle. So we can simply read it from the triangle. Cos theta is 1 over square root 5. Now that depends if you want to leave the answer in that form or rationalize it. 1 by square root 5 cos theta is 1 by square root 5 into square root 5 by square root 5 would be square root 5 by 5. Calculator is allowed. Calculator will also do this step for you. Tan theta, again from the same triangle, perpendicular over base or opposite over adjacent. Tan theta is 2 by 1, which is 2. Sin theta over tan theta minus cos theta, we already have values for all three of them. Just simply substitute. Sin theta is given 2 by square root 5. We just did tan theta, that is 2. Cos theta, that is 1 over square root 5. And simplify it. Taking LCM, 2 square root 5 minus 1. Get rid of these. And I'm left with 2 over 2 square root 5 minus 1, which could be rationalized, simplified mode. Okay, these are the two triangles we covered in simple math. Let's quickly revise them. And we need to know them by heart. Wherever calculator is not allowed or working needs to be shown, we use the same triangles. Consider this an equilateral triangle of side 2 each. If this is equilateral and this is 2, we know that all three of them would be 2 and all the angles will be 60 degrees. Now my desired triangle is half of this. Half of this. So base now becomes 1. This is 2. To solve the third side, hypotenuse square is equals to 1 square plus unknown square. 4 is equals to 1 plus x square. 3 is equals to x square. X is equals to square root 3. Now we can just memorize this triangle. We don't need to solve it again and again in any question. So the angle stays 60. This angle is 90 degrees. This is half of the original. That becomes 30. So we have to memorize this triangle for 30 degrees and 60 degrees for sine cos tan, 30 and 60. We would know the exact values without calculator as well. The other is made by drawing a square of side 1 each. And half of the triangle is the required one. 90 degrees, this was 1, this was 1. Drawing the diagonal makes this 45, 45 each. Solving the third side, hypotenuse square is equals to 1 square plus 1 square. Hypotenuse square is equals to 2. Hypotenuse equals square root 2. Now we can just use these two triangles to answer for, let me just fit in here, sine 30, cos 30, tan 30. And then sine 60, cos 60, and tan 60. Use the triangle and try give the answer for these ratios: sine 30, cos 30, tan 30.
So then sine 30 would be 1 over 2.
Correct. Cos 30.
Square root 3 over 2.
Correct. Tan 30.
Square root 3 over 1, so just square root 3.
The other way, tan 30. That is opposite over adjacent. 1 over square root 3.
Oh, okay.
Now try sine cos tan 60.
So sine 60 square root 3 over 2.
Square root 3 by 2. Cos 60
1 over 2.
and tan 60.
And then square root 3.
Square root 3. Now see one thing. Sine 30 is actually equal to cos 60. And cos 30 is equal to sin 60. Can you see that?
Yes.
And the last one, tan 30 and 60 are reciprocal of each other. So indirectly, if I just label them as A, B, and C, let me switch those coordinates. A, B, and C. So whatever is sine of A is equal to cos of B. So I can devise an identity A, B, C. I can say sine A is equal to cos B. Making it more generic would be sine theta is equal to cos 90 minus theta. If this is 10, obviously that would be 80. So sine theta is equal to cos 90 minus theta. That is one of the identity. And if we just look at tan, they are reciprocal of each other. So I can write tan theta is equals to 1 over tan 90 minus theta. They are reciprocal of each other.
Sine A equals sine A equals cos B. So sine A is 10 and cos B is 80, right?
Those are the angles. I could say that sine 10 is equal to cos 80.
Yes.
Sum needs to be 90 degrees.
And if it was 10 equals 1 over 1080.
1 over 1080. So triangle of 45 done. Sine cos tan 45. And definitely we can also change them in radians. For radians, we know that 45 is 180 divided by 4. So 45 will be pi by 4 and pi by 4 in pi by 2. For 30, 60, 90, 60 is 180 over 3. So this is pi by 3. 30 is 180 over 6. So this is pi over 6. And this is pi by 2. 1, 2, square root 3. Everything else stays same. So inverse tan ratios, we just deal either in degrees or in radians. Okay. Find the exact values of sine 45, 60, so on. Now, definitely, we can get this with calculators as well, but whenever the examiner says this, we just have to show each and every step. So sine 45 degrees into sine 60 degrees, we are working for exact values, no decimals, nothing. And I just remember triangle, I'm writing it quickly. This was 60, 30, 1, 2, square root 3. And
So
then
sorry, would it be the same if it was like reverse? Like so sine theta equals cos 90 minus theta? Would it be
same.
cos theta equals sine 90?
Yeah,
So it would be the
same.
same, right?
Because this cos theta is equals to sine 90 minus theta. The theme is to keep the sum of these two 90.
Okay.
Like if I write cos of 20, that would be 90 minus 20. So that's sine 70. Sum is still 90. So it is true.
Okay.
Okay. So sine 45 and sine 60, we just got done with the triangles. So sine 45, I can see 1 by square root 2 times sine 60 is square root 3 by 2. So that's square root 3 over 2 square root 2. And I'm rationalizing it in the same step. So that's 2 square root 6 over 2, 2 times 4, 4, 2 times 8, 2, 1 times 2, 4 times square root 6 by 4. Similarly, cos square, just substitute the value of cos 45 and then make it square. And then in the last step, that is tan pi by 3. Pi by 3 is actually 60. This is pi by 3. This is pi by 6. This is pi by 4. So tan pi by 3 is tan 60 square root 3 by 2. Sorry, square root 3 by 1. Tan 60 plus sine pi by 4 is sine 45, 1 by square root 2 divided by 1 minus cos pi by 3 is again 60. So that is 1 by 2. And we could simplify this. The denominator is simply 1 by 2 square root 3 plus 1 over square root 2. And the denominator is 1 by 2. It goes up, multiplies by 2. So 2 square root 3 plus 2 over square root 2.
How does it go up?
Simple. Denominator is 1 by 2. Square root 3 by 1 plus 1 by square root 2. And the denominator was 1 by 2. This is being divided. So I multiply it with 2 over 1.
Oh, okay.
And now taking LCM, square root 2, 2 square root 6 plus 2. Rationalize further, 2 square root 6 plus 2. Over square root 2 into square root 2 by square root 2. How? We could have simply just done it with the second term only. Let's see if I get the same answer. This is 6, 2 times 12. 2 square root 12 plus 2 square root 2 over 2. I'm simplifying 12 first and then taking out common. 12 is 2, 6 times 2, 3 times 3, 1. So square root 12 could be written as 2 square root 3. 2 square root 3, 2 times 4 square root 3 plus 2 square root 2 over 2. Taking out 2 common in numerator. 2 square root 3 plus square root 2 over 2. 2 cancels out. 2 square root 3 plus square root 2. Okay, exercise 9.1. This is 9.1. Okay. Try a few parts of 9.1 and we'll check the answers. Start with this.
9.1?
Yeah,
Okay.
you'll have to draw a triangle. How many are done?
Sorry, could you please repeat that?
Yeah, how many are done?
I'm almost finished with the first one.
Okay.
Yes.
Done the first one? Okay, let's check. This is 9.1, question 1A. 2 square root 13 by 13. Are you getting this? 2 square root 13 by 13
For A part?
for A part.
No, I'm not.
What are you getting?
I'm getting 2 over square root 13.
Yeah, that's right. You just need to rationalize it.
Oh, okay. Do we have to always rationalize it?
Always, yes.
Okay.
Because thirds is also part of syllabus and we need to simplify them.
Okay.
See these answers? There's none in where you will find square root in the denominator.
Okay.
Probably all these three questions would use the same concept, just different values.
So then do I continue with 2?
Uh, how many parts have you done? 9.1.
I've done the first part. So
First
should
part.
I continue?
Try um, D and E as well.
Oh, I
Because the
have,
concept is same,
yeah.
the values are different, so we'll be using same triangle, D and E.
I have done D&E as well.
Okay. First, all parts or these
Yes.
three? Just
All
compare
parts.
the answers.
Okay.
If there's any mistake, we'll discuss, then move on.
I don't get D part. Like everything else is correct, but D part I'm getting 5 by 13.
Okay, D part. So this was like this. This is tan of theta is opposite over adjacent, and applying Pythagoras theorem is square root 13. This is sine square plus cos square. So sine is 2 by square root 3. 2 by square root 13 square, and cos square is 3 by square root 13 square. 2 square
Oh,
is,
addition.
yeah, yeah.
Oh, I saw the subtraction. I was
9 by
subtracting them. Okay.
13 by 13 is 1. Okay. I'll do a few questions from 2. So first of all, it is given that sine theta is equals to square root 2 by 5. Let this be a triangle, right angle triangle. It is given that it is acute. So theta is perpendicular over hypotenuse. Now solving for the third side, 5 squared is equal to square root 2 square plus x squared. 25 equals 2 plus x square. 23 equals x square. X equals square root 23. square root 23. Now we have all the values and we can solve the ratios. Let's say to A is cos theta, so that is square root 23 over 5. B is tan theta, square root 2 by square root 23, and we rationalize. 2 into 23 is 46 over 23. C part is 1 minus sine square theta. 1 is there, and sine square. Sine theta is given in question, square root 2 by 5. 1 minus 2 by 25. 25 by 2 by 25. 23 by 25. And D part, sine theta plus cos theta. Sine theta is right in front of us, that is square root 2 by 5, and cos theta is square root 23 by 5. So that's square root 2 plus square root 23 over 5. E part is cos theta minus sine theta over tan theta. I'm picking up some values from the screen. This cos theta is square root 23 by 5, sine theta is square root 2 by 5, and tan theta, going back to the original diagram, is square root 2 by square root 23. Simplifying. LCM in the numerator is 5. Square root 23 minus square root 2 over 5, and we were dividing by this, so it would multiply with square root 23 over square root 2. First of all, I'm keeping it as it is, square root 23 minus square root 2 by 5, and rationalizing the other part only. Square root 23 over square root 23 into root 2 over root 2. I'm writing it as factors so I can see where to just make square of that. Now if I multiply these two, I can see root 23, root 23. So that would be 23 square root 2. Then the second 2, I can see that 2 coming out, and root 23 over 5, 2 times is 10. Let's see the answers. 9.1 question 2. 23 over 5, first one. Second, tan theta is root 46 over 23. Third is 23 over 25. Fourth is root 2 plus 23 by 5. And fifth is 23 root 2 minus 2 root 23 over 10. Now question 3 is again on same nature. We can leave that for practice. And coming on to question number 4. Now to solve this,
Question 3.
now 4. We're leaving question 3 for practice.
Okay.
Exactly on the same nature. Now looking at question 4, you would need to draw two triangles for 45 and 60. Definitely calculator will also give you exact value of 10 45 times cos 60, but we need to show the working. If you don't remember them, I can draw them for you, the triangles.
No, it's okay. I know the triangle. So basically, I know that like it's 1, 1, and then square root 2, and then 45 degrees.
Correct.
And then the second one is square root 3, 1, 2, and then 60 degrees and 30 degrees.
That's right.
Well, A has to be 1/2 because, well, tan 45 equals 1, and then cos 60 equals 1/2.
Cos 60, yes. 1 into 1 by 2 is just 1, 2. That's correct.
B is going to be 3.
60 squared, 3, correct.
C is 2 out of 3. 2 over 3.
Correct.
I have I have both the values for D, the sine 45 and the cos 30, but
Oh,
then
yeah.
adding them is
Okay. Let me show you. Sine 45. This was question 4D part. Plus cos 30. And using the triangle, sine 45 is 1 by 1, 1 by square root 2, and cos of 30 is square root 3 by 2. Now, before taking LCM, I would rationalize the first term, 1 by square root 2 into square root 2 by 2 plus square root 3 by 2. We'll just keep it as it is until we rationalize. Now, see the denominators are same, simply add them. Done. If you would take the LCM first, the answer will be same, but it would take more steps to simplify it. Is this clear?
yes.
E part.
6/4 square root 2.
Question 4. E is something else. 6/4 square root 2. We have something else. This plus minus sign and rationalizing. E part is cos square 30 over cos 45 plus cos 60. So 30 is square root 3 by 2 whole squared over cos 45 is 1 by square root 2 plus cos 60 is 1 by 2. Numerator is squaring, that is 3/4, in denominator I'm rationalizing the first term first, plus 1 by 2. This is 3 by 4 over root 2 by 2 plus 1 by 2. 3 by 4, that is root 2 plus 1 over 2. So when it is being divided, we take the reciprocal into 2 over root 2 plus 1, 2 1 times, 2 2 times. So this is now 3 over 2 square root 2 plus 2. And we rationalize again. 2 root 2 minus 2 over 2 root 2 minus 2. For now, I'm just taking out common. 2 on right hand side, 2 3 is 6 into root 2 minus 1. over a square minus b square. The 2 square is 4 into 2, 8. B square 2 to the 4, 6. Root 2 minus 1 over 4. 2 2 times, 2 3 times. 3, 2 minus 1 over 2. 3 multiplied inside is 3 root 2 minus 3 over 2. Clear?
Yes, sort of. So when I was doing it, I also rationalized it like you did with the 1 over square root 2.
Yep.
And I got square root 2 over 2 plus 1 over 2.
Yep.
But I think instead of like keeping that in mind as square root 2 plus 1, I kept that in mind as square root 2 over 2.
Okay. Okay.
So yeah. But then afterwards we simplified it.
Yes.
So it's 3 over 4, so that's 3 over 2. So oh yeah, it was like a cross multiplication.
Whenever you get chance to rationalize before taking LCM, go for that. Things simplify out more. Okay. This is 3 root 2 minus 3 by 2. Let's try one with radians. Select any.
F.
Okay. Question 5, part F. This is tan pi by 4 minus sine pi by 4 divided by tan pi by 6 multiplied with sine pi by 6. And we already have those triangles. We can fill in those. 45 is pi by 4, 60 is pi by 3, 30 is pi by 6. And just copy the values from the same triangle. The tan pi by 4 is 1. Sine pi by 4 is 1 by root 2. Tan pi by 6 is 1 over root 3. And sine pi by 6 is 1 over root 1 over 2. Can you just quickly double check if I copied the correct values?
Okay.
Okay.
So yeah, 10 pi by 4. That is yeah 1, and then minus sine pi by 4, and that's 1 over square root 2 over 10 pi by 6. And yes, 1 over square root 3. And then sine pi by 6. Yeah, 1, 2, 1 half.
Now taking LCM in the numerator. This is again, these are just numbers now. So root 2 minus 1 over 1 over 2 root 3. And I'm rationalizing there and then 2 minus 1 over root 2 into root 2 by root 2 over 1 over 2 root 3 into root 3 root 3. So root 2 into root 2 is 2 minus square root 2 over 2 divided by square root 3 over 6. 2 minus square root 2 by 2 into 6 by root 3. 2 1 times, 2 3 times. 2 minus root 2 into 3 over square root 3. I'm rationalizing the second part only. 2 minus root 2 into this was 3 over root 3 into root 3 by root 3. So this is 3 root 3 over 3. This cancels out. Or 2 root 3 minus root 6. This was question 5 part F. 2 root 3 minus 6. Okay. Next concept. The general definition of an angle. You need to be able to use the three basic trigonometric functions for the angles. To do this, you need general definition for an angle. So angle is just measured or measure between two straight lines subtended out. An angle is measure of rotation of line OB about a fixed point. The angle measured from positive x-axis and anti-clockwise is taken as positive and clockwise is taken as negative on the Cartesian plane. Starting from the first quadrant, to draw diagram using quadrant in which the rotation of OP lies for each of these. So 240, before doing that, we know this is 0, 90, 180, 270 and ends at 360 again. So you just know that 240 is more than 180 and less than 270. So it would be somewhere here. This is 240. Then negative 70, we have to go clockwise. This is in the fourth quadrant. 490. Now definitely that's more than 360. 360 and 490. The difference is 130. Minus 360, it is 130. So basically it rotates and then it goes again. So 130. So it is coming here. You will draw 130 over here and label this as 130. 490 and 130 are same thing. 2 pi by 3. Now these are in degrees. I'm changing it into radians. This is 0. This is pi by 2. That's pi. This is 2 pi. And this is 3 by 2 pi. Now 2 divided by 3 is 0.66. That's definitely less than 1 and more than 0.5. So it lies in the second quadrant. This is 120 degrees actually. Okay. Draw a diagram showing the quadrants in which the rotating line OP for each of the following angles in each question indicate clearly the direction of rotation. So definitely positive and then anti-clockwise and negative is clockwise. If I'm drawing 110, I know that's more than 90. 60 clockwise is here, 220. I know anti-clockwise because it is positive. So 0, 90, 180, 270. So in between 180 and 270. Try these last two, 135 and minus 135 and minus 300. We have them drawn out, yes.
So minus 135 would be in the negative direction. So it would be like after the 360 line. So then that should be above the, like beyond the 270 line.
Yes, this is quadrant 1, 2, 3, and 4.
So
So in
quadrant 3.
quadrant 3. And negative 300.
So then that should be quadrant 4. I mean, quadrant 2.
What about quadrant 1? This is 300.
Oh, right before 60. Okay.
And similarly for radians, like one would just need some practice because usually we don't see them too much around. So 3 by 4 pi, sometimes I do have to convert it for myself, but I'm just trying to stay in radians. So in this case, I would know that this is 0, this is 0.5 pi, this is 1 pi, this is 1.5 pi, this is 2 pi. So that would somehow help me that 3 by 4 is 0.75, so it has to be more than zero point 0.5 and less than pi, less than 1. So in the second quadrant, whereas 7 by 6 is clearly more than 1, and 7 by 6 is giving me 1.16, which is more than 1 and less than 1.5. While we speak, I'm looking at the grid I've drawn on the bottom right side. So this is 1.16, definitely more than the second quadrant. It lies in the third one. And this is negative. We have to go clockwise. So 5 divided by 3 is more than 1.5. So it is in the first quadrant. Any confusion in H part?
So negative 5 pi over 3 is greater than
Greater than
0.5 pi?
8%. Pi
Greater
by
than.
1.66. Let me enlarge that. Negative pi by 3 pi is negative 1.66 pi. So if I just move in this direction, this is 0. This is zero point 0.5. This is 1. This is 1.5. So it is more than 1.5. That is 1.66.
Oh, okay.
Try I part. State the coordinate number.
So that's in the second quadrant.
That is not in second quadrant.
But isn't it equal to 1.44?
Yeah, that is 1.44. That means it is more than 1. See, this is 0.5. This is 1. So more than 1. This is the third quadrant.
Oh, wait, this one's not negative, so it doesn't go in the opposite direction.
Yeah, that. Okay, that was positive. Last one. 5 by 8.
0.625, and that is right after 0.5, but it's negative, so it's in the fourth quadrant.
That's more than zero point 0.5. So it's
Oh,
in
so
the
it's in the third quadrant.
third quadrant. 2 is having the same nature. Quadrant number. Okay. We've discussed some of them indirectly. Trigonometric ratios of journal angles, sine theta, cos theta, tan theta. The triangle is showing us x, y, and r. This is x, this is y, this is r. So using the same. Sine theta is y over r, cos theta is x over r, tan theta is y by x, where x is not equal to 0. That's in denominator.
Why do they have to specify that x is not equal to 0?
Because denominator can't be 0. X is in the denominator.
Okay.
For example, if one would consider that this is moving around, it could be here, R could be here. This is y over x, but it can't be vertical. X can't be 0.
So vertical on the y-axis is 0, and the horizontal is infinite. No.
Like just the consideration because x is in denominator and we know that would be math error.
Hmm.
So, for example, if I just draw this triangle and ask what is the value of tan 90, where tan is opposite over adjacent. Now, what would you consider as opposite side and which side is as adjacent side? So you can do that. So that would be actually 1090. And if you just punch in 1090 in calculator, see what you get.
1090, I get negative 1.995.
Uh, your calculator is in radians, I guess. If that's
Oh,
so,
it says
in
complex infinity or
yes.
something like that.
So just try 1089.
57.289 dot dot dot.
Correct. Just put in 1.9, like 89.9. See, it increases 10 times.
Yes.
Now, if you just punch in few point nines, 89.999, few nines, and see what do you get.
It keeps multiplying by 10, so it's like a larger number each time.
So when it is going closer to 90, it shoots up. Now, if you just look at tan theta on the screen, that is y over x. So x is actually becoming significantly small. So definitely the overall value would shoot up and it would not touch 90 degrees. It would not touch 0. We will draw graphs for sine cos tan in the upcoming classes to understand the answers for 0, 90, 180, 270, 360. We've already covered 30 degrees, 45 degrees, 60 degrees. And for these 0, 90, 180, 270, 360, we'll be looking at graphs. Other than these values, calculator.
Okay.
So simple ratios, and then we can use these ratios to make identities as well in later classes. Okay. Express in terms of trigonometric ratios of acute angles. This is minus 110, negative 110. We know 0, 90, 180, 270, and 360. Now, this negative 110 is coming somewhere here, more than 90. This is negative 110. Agreed or not?
Yes, because it passes a 90 in the
Yeah.
negative way.
And we know that this was add sugar to coffee. Simple math. Do you remember that?
Yes.
So this is cos negative 110 and add sugar to coffee. Definitely we know it is cos and it would give me finally it would give me a negative answer.
Okay.
But when I'm looking at 110, may I say this remaining angle is 70 degrees?
Yes, because I would, yeah.
And we know that cos theta is equals to cos 180 minus theta, but with a negative sign.
So then it would be positive 70, right?
Yeah, we'll work that. Do you just remember this? Sine theta is equals to positive sine 180 minus theta because
Oh,
sine is positive in both of them.
okay. Wait, no, sine is positive. I understand that the sign is both positive in the first and second, but then in the formula itself, why is it positive on both sides?
Because we are just talking about 180. So if it is acute, this is definitely positive. If it is obtuse, this is again positive. That is why sine is positive on both sides.
Okay.
If we look at cos, cos theta is positive in first, but when we go in the second quadrant, that is cos 180 minus theta, it would give us a negative value. And we're multiplying with the negative sign just to have an equality.
Okay.
And the third one, tan, same thing as cos. Tan theta is equal to negative tan 180 minus theta. Now coming to the original question, we know that this is 70 basic angle, concept of basic angle. If the basic angle is same, value is same, we just need to understand that it would be positive or negative. So cos 70, 110, I'm writing it as cos 70 because the acute angle is 70. So cos 70, but I know cos 70 would be positive and this in fact was negative. So I'll write minus cos 70. Now this is being expressed as acute angle and this sign is also correct. If I look at sine 125, this would lie here. I know the remaining angle is, I'm subtracting it 180 minus 125, the remaining angle is 55. So sine 55, and I'm also checking the signs. That was positive. This is still positive, so no change is required. This is sine 55 straight away. Clear?
Yes.
Okay. So this exercise would just use the same concept. Try a few questions in your free time.
Okay. Wait, which page is this?
Yeah, yeah. This is 200.
200. Okay.